So, a big part of feature engineering is imputation of missing data. What do you do when your data has missing data elements in it? This is what happens in the real world. For every observation you have, there's going to be some missing data points, more than likely. Well, a simple solution is just called mean replacement. The idea is that if you have a missing attribute or feature within one of the rows of your data, just replace it with the mean from the entire column. And remember, we're talking about columns, not rows here. You want to take the mean of all of the other observations of that same feature. It doesn't really make sense to take the mean of all the other features for that row, right? So mean replacement is all about taking the mean of that column and replacing all the empty values with that mean. So it's fast and it's easy. Those are some of the positives of this approach. It also doesn't affect the mean or the sample size of your overall data set because you're just replacing missing data with the mean. It won't affect the overall mean of the entire data set, which can be nice. Now, one nuance is that if you have a lot of outliers in your data set, which is also something you have to deal with when preparing your data, you might find that median is actually a better choice than the mean. So if you have a data set of a bunch of people and maybe one of those columns is income and some people don't report their income because they think it's sensitive, you might have your mean skewed by a bunch of millionaires or billionaires in your data set. So if you do mean imputation in that sort of a situation where you have outliers, you might end up with an overly high or overly low value that you're using for replacement. So if you do have outliers that are skewing your mean, you might want to think about using median instead. That will be less sensitive to those outliers. But generally speaking, it's not the best choice for imputation. First of all, it only works on the column level. So if there are correlations between other features in your data set, it's not going to pick up on those. So, if there is a relationship between, say, age and income, that relationship is going to be totally missed. So you could end up saying that a 10-year-old is making, $50,000 a year because that's the mean of your data set, but it really doesn't make sense, right? I mean, a 15-year-old wouldn't be making that much money yet. So it's a very naive approach from that standpoint. The other issue is that you can't really use it on categorical features. How do you take the mean of a categorical piece of data? That just doesn't make sense, right? Although you could use the most frequent value that appears. The most commonly seen category would be a reasonable thing to do in that case. It's sort of in the same spirit as mean replacement, but not really the same thing. Overall, though, it's not going to be a very accurate method. It's a very ham-handed attempt at doing imputation. So although it's quick and easy and has some advantages, in practice, if someone's asking you, say on a certification exam, what's the best way to do data imputation, mean replacement probably isn't it. It's also probably not just dropping the missing rows, although, as we've seen, sometimes that's a reasonable thing to do. If you do have enough data such that dropping a few rows doesn't matter, if you don't have too many rows that contain missing data, well, it doesn't sound that unreasonable. The other thing, too, is that you want to make sure that dropping the rows that have missing data doesn't bias your data set in some way. What if there's an actual relationship between which rows are missing data and some other attribute of those observations? For example, let's say that we're looking at income again. There might be a situation where people that have very high or very low incomes are more likely to not report it. So by removing or dropping all of those observations, you're actually removing a lot of people that have very high or low incomes from your model, and that might have a very bad effect on the accuracy of the model you end up with. So you want to make sure that if you are going to drop data, that it's not going to bias the data set in some way as a byproduct, right? So it's a very quick and easy thing to do, probably the quickest and easiest thing to do. You can literally do this in one line of code in Python, but it's probably never going to be the best approach. So again, if an exam is asking you, what's the best way to impute missing data? Dropping data probably is not the right answer. Almost anything is going to be better. Maybe you could just substitute a similar field, right? I mean, that would also be a simple way of doing it. For example, I might have a data set of customer reviews on movies, right? Maybe if I have a review summary and a full text review as well, it would make more sense to just take the review summary and copy that into the full text for people who left the full text blank, as an example. So almost anything is better than just dropping data. But, in the real world, if you're just trying to do something quick and dirty and sort of like start experimenting with some data just to start playing with it, it can be a reasonable thing to do. I just wouldn't leave that in place for production necessarily. The thing you probably really want to do in production is by using machine learning itself to impute your missing data into your machine learning training. So it's a kind of a meta thing. There are different ways of doing this. One is called KNN. That stands for K nearest neighbors. And if you have any experience with machine learning, you probably know what that is already. The general idea is to find the k, where k is some number, of the most similar rows to the ones that you're looking at that has missing data, and just average together the values from those most similar rows. So you can imagine having some sort of a distance metric between each row. Maybe it's just the Euclidean distance between the normalized features within each row or something like that. And if you find the, say, 10 nearest rows that are most similar to the one that's missing data, you can just take the average of that feature from those 10 most similar rows and impute the value from that. So that takes advantage of relationships between the other features of your data set, which is a good thing. One problem with it, though, is that that idea assumes that you have numerical data that you're trying to impute and not categorical data. It's tough to take the average of a category, but there are ways of doing that with techniques like Hamming distance. But KNN is generally a better fit for numerical data, not categorical. If you have categorical data, you're probably better served by actually developing a deep learning model. Neural networks are great at doing categorization problems. So the idea would be to actually build a machine learning model to impute the data for your machine learning model, right? It's a kind of a cycle there. And that works really well for categorical data, really well. It's tough to beat deep learning these days. However, of course, it is complicated. There's a lot of code involved and a lot of tuning as well. But it's hard to beat the results. If you actually have a deep learning model that tries to predict what a missing feature is based on other features in your data set, that's going to work out. A lot of work, a lot of computational effort, but it's going to give you the best results. You can also just do a multiple regression on the other features that are in your data set. That's also a totally reasonable thing to do. And through regressions, you can find linear or nonlinear relationships between your missing feature and the other features that are in your data set. And there is a very advanced technique along these lines called MICE, which stands for multiple imputation by chained equations. It's kind of the state of the art in this space right now for imputing missing data. So, all right. And finally, probably the best way to deal with missing data is to just get more data. So if you have a bunch of rows that have missing data, maybe you just have to try harder to get more complete data from people. And it's hard to beat just getting more real data so that you can just not have to worry about all the rows that have missing data. Again, you want to be careful that if you are dropping data, that you're not biasing your data set in some way. But really, the best way to deal with not having enough data is to just get more of it. Sometimes you just have to go back and figure out where that data came from and collect more, better quality data. So the better quality data you have going into your system, the better the results you will get. And while imputation techniques are a way to cover up issues where you just don't have enough data and you can't get more of it, it's always a good idea to just get more and better data if you can.